In today's presentation, I'll share with you some information related to the triple helix model. Then we will review some examples of the mechanisms of aligning the higher education with the national objectives. Also, we are going to discuss a couple of models related to the university industry collaboration and see some examples from different countries and from different parts of the world. So I would like to start with, in today's research environment, it is undergoing a paradigm shift where it requires a greater focus on integrity as well as societal impact measures. With the rise in the global competition, academic and government leaders increasingly need actionable information to make informed strategic decisions, which will impact the organizations for years to come. So our intelligence helps people to think forward, driving academic impact through advancing research excellence by coupling our expertise, content, tools with the collective insights of the community. This allows us to provide powerful intelligence and innovative solutions that help people to navigate, change, and champion their institution's success. There are three main pillars placed in the ecosystem of research landscape. The academic institutions, government represented by the ministries of the higher education. Government set national priorities, regulations, and fundings, and act as the steering committee that can help institutions to make the informed decisions. Also, they are playing a big role on the funding and how they drive the R&D responsibilities. Industry's main role is to create jobs and to ensure that they are investing through the right R&D offerings and help to update the objectives and create the jobs required for the community. The three sectors in most of cases are working in silos. They are not communicating. They are not talking together. So what we are trying to do and what we are sharing here is some models that will help you to understand how can they work together, starting from the linear model, going into the triple helix and other models. So we'll start with the focus of the international policy reviews, stress that the higher education systems could be guided by the national strategies, so the institutional missions, funding, and programs are aligned with the national economic, societal, and developmental priorities. Hopefully, this will help the institutions to play a bigger role in the 21st centuries as the key foundation and the key founder for the custodians of the national competitive advantages. Also to balance the competitiveness with the local educational needs. The high engagement and strong interactions among universities, industries, and government help universities to become entrepreneurial, focusing on commercialization and tech transfer. Government to act as the facilitator and regulators, industry to drive market-oriented innovation. Also encouraging the joint ventures, encouraging the innovation clusters, and the knowledge exchange. The triple helix model evolves as institutions internally transform and act as adopting the other's role. For universities, that means embracing both rapid commercial outcomes and broad government goals for societal impact. This represents the evolution of all those models, starting from the linear innovation model, going into the triple, quadruple, and quintuple models. The linear innovation model, as you all know, it's a sequential process where it starts from the basic research, going into the applied research, then development into the product, into the market. This model was dominant some years ago, and it is like for decades has been the dominant model. The triple helix model is strong interaction among universities, industries, and government. After that, the society started to play a role into this model and act as one of the components and one of the constituents of this model and shape the innovation acceptance. And after that, environment and the sustainability started to be an added metric into the innovation model. and helped into the overall outcome of those dimensions. Clarivate is approaching the topic of the societal impact by developing an evaluation framework which depends on a wealth of data that comes from the academic and government, intellectual property, life sciences, and healthcare. Also with more than 5 decades of expertise and analytical experience in the responsible use of metrics and methods. The framework is derived from the enhanced pistol model. Going into the aligning, how to align the higher education with the national priorities, there are 4 approaches. The first one is the national curriculum and syllabus alignment. The second one is the program level reform to match strategic sectors. The third approach is the workspace-oriented graduation pathway. And the fourth one is the national research and innovation alignment. There are some examples of those approaches that will be discussed in the following slides. So the first approach is the national curriculum and syllabus alignment, where we have 3 countries here that they are using this approach. I'll start with the Singapore government example, which is they are working directly with universities to update the courses according to the sector roadmap, like the AI or the cybersecurity. Each discipline has a competency framework that guide the outcomes, the industry skills, and graduate capabilities. From the UAE, universities align their programs with the national priorities like the AI, like the renewable energy, space, and health technologies. Accreditation bodies also require evidence that those courses include the nationwide skills and required industry engagement and employability pathways. And in Finland, the third example here, that the Finnish universities co-design courses with industry in sectors like ICT, clean energy, and bioeconomy. Each curriculum must demonstrate labor market relevance through documented industry consultation. There are a few examples also on the second program, or the second approach, which is the program level reform to match the strategic sectors. Comes from South Korea, where they initiated an initiative that funds universities through developing programs with companies. Departments are incentivized to create applied curricula, joint labs, industry-led teaching models. And this model is very well accepted, and it has great results that came out of it. The second model that I would like to share with you today is coming from the US, where the engineering research centers integrate academic programs with industry-sponsored research. Students are trained through problem-solving based industry-defined research that fed directly into the national priorities within the country. And in the UK, the universities receive funding to build programs around data science, robotics, quantum technologies, and clean growth. The third approach here, which is about workspace-oriented graduation pathways, comes from Saudi as well as Germany, where in Saudi they align the higher education output with the Vision 2030 skill needs. Universities must demonstrate their admission quotas and graduate numbers reflecting the labor market forecast in sectors like medicine and engineering. Also in Germany, students spend part of their degree working in the industry, and companies contribute to programs as well as the tuition for those programs. This creates highly aligned pipeline in engineering, IT, and applied sciences. So if we look at the US model, the US approach is shaped by decentralized innovation system, plus universities with considerable autonomy, plus commercialization publicly funding research. System traces its roots to the Bayh-Dole Act of 1980, which granted universities the right to own and license inventions arising from federally funded research. Those are the 5 components or the 5 key features of this model, where the Tech Transfer Office is managing the IP, supporting the spin-offs, the entrepreneurships from the university incubators and accelerators are present within the institution. The federally funded research programs from the big funders like NIH or NSF are specifically targeting academia for specific topics. The market-driven approach, competition between universities, firms, and regions on funding, and guiding the market signals not by any centralization, by very decentralized approach. And the impact orientation here is mainly commercial pathways that dominates the outcomes of those innovations. The European model employs a coordinated policy framework, linking universities, government, and industry for shared innovation goals. So structured governance and public funding instruments promote accountability and inclusivity in partnerships. European partnerships prioritize societal challenges like sustainability, public health, beyond the commercial goals. And if we look at the details or the key features of the European model, you will find that it is driven by mainly policy, and usually it drives by some programs or some objectives, and those objectives are defined by the European Union, and those programs are getting the funding because the people need to search according to those programs. Mission orientation, interdisciplinary cooperation for shared goals. The EU-funded projects require innovation with demonstrated societal impact. The multi-actor governance here specifically about identifying the clusters, the technology platforms, and the innovation hubs connect universities, firms together to drive the cooperation. The strong public funding accountability. Funding programs require clear dissemination and social and societal impact to ensure transparency and accountability. And last but not least, moderated commercialization environment where the European universities retain the IP ownership, the ethical commercialization framework, and avoid concentration of resources. The third model here, which is the South Korean model, consists of three components. The entrepreneurial university activities, where South Korean universities emphasize commercialization, patent generation, technology licensing, and startup creation to drive innovation. The second component is the government-coordinated national programs, which provide targeted funding and enforces regulation to align innovation efforts with national goals. And the third component is the balance between the entrepreneurial flexibility with coordinated national strategies, achieving strong commercialization and innovation outcomes. The South Korea has built a system of industry-university collaboration that combines the features from both the US and European approach, focusing specifically on institutional backbone. Like the US, it places strong emphasis on the commercialization, IP management, and university-driven entrepreneurship. Universities are expected to generate the patents, license their technologies, and create the startups. And after some time, the Korean government plays a coordinated role closer to the European model, using national programs and targeted funding to align university activities and national priorities. The South Korean model outcomes also build on performance-based funding, measurable outcomes, centralized evaluation, and culture of accountability. Looking at the four components here, starting with the market-driven entrepreneurship flexibility or entrepreneurial flexibility, universities have the freedom to pursue patents, startup, industry partnership, fostering innovation and commercialization. The state-led strategic coordination, government has the oversight and the aligned activities with the national goals, like technology advancements with the regional development. The hybrid commercialization governance here allowing the South Korean model to blend with the US commercialization and the European governance to support the global competitiveness. And the last point is synergistic innovation ecosystem, where combining the market incentives with governance reduces the fragmentation and foster equitable resources distribution and innovation.